Hello, Internet, and thank you very much for joining the Cloud Native FM podcast, a show where you meet awesome mind behind awesome tech. And this show will help you keep track of cloud native, containers, DevOps, Kubernetes ecosystem. And by listening to this show, you will get to know where the Kubernetes ecosystem is heading up to. And let's talk about what we are covering today. Wolfi, the first Linux un-distro designed for securing the software supply chain, powered by some genius and hardworking folks at Chainguard. If you are running containers in production, and mostly you are, you end up facing issues include container images tend to lag behind upstream updates, resulting in user running images with known vulnerabilities. The common distribution used in container images also lag behind upstream versions, resulting in user installing packages manually or outside of package managers. Container images typically contain more software than they need to, resulting in an unnecessarily increased attack surface. Many container images have no provenance information, making it difficult to verify where they come from or if someone has tampered with them. They are typically not designed to meet compliance requirement or standard like SLSA. So let's go straight to our guest and start learning about some buzzword in software supply chain security, provenance, signatures, and software build of materials. So thank you very much for joining. And I go to Erica Heidi, developer experience at Chainguard. Thank you very much for joining the show. So can you give a brief intro of yourself to our audience?
Yes, sure. Hello, everyone. Thanks for having me, Saim. And so I'm Erica Heidi, and I work as a developer experience engineer at Chainguard. So I'm involved with documentation and educational resources, and also learning about the tools so that I can teach how to use them, help developers make the best of the tools that we develop. And we, in the last few months, I've been involved with the projects that we have that are related to container images, building better container images. So that's what I'll be talking here today. So we have a few different open source projects that power our products. And so, yeah, I'm going to talk a little bit about Wolfi as well. And then I will talk about the tools to show a more technical overview of how Wolfi is built. That's kind of what this goes, where this goes. I actually had a talk about APQO specifically, and I just added a few slides. So I'm going to talk a little bit about the overview of how these tools interact together, like how they relate to each other, and how we use them to build Wolfi. And also, I will show some files how the packages are built. So I'm going to give a little. Maybe we can try a demo. Let's see how it goes.
Yes, absolutely, absolutely. And if you want to share your screen or start talking
Okay.
about on the slide, you can definitely do that. And I will ask question. And also, people who are listening to us or watching us, please put your question on the chat, and I will add those to the Erica, and we will answer all those. In. So this is a great place to talk about containers or any question related to software supply chain security. And plus, there's a KubeCon coming up next week, and there is a Six Store Con that is happening, I think, in 25th of October. There's a very wonderful list of talks that you should want to listen to. So go and try to get involved with the Six Store community. And now I'm sharing the screen on this for everyone. And now, Erica, you can start talking about it.
All right. So let's get started. So I'm going to talk about Wolfi, APQ, and Melange that are OSS kind of a toolkit for container images that we developed. So I will start with an ecosystem overview and talk a little bit how these projects work together. So let's start with Wolfi. That's like the everyone is talking about. So Wolfi is nothing less, nothing more than a tiny Linux distribution, and we call it an un-distro because unlike regular Linux distributions, there is no kernel, there are no like man pages, and there's not a lot of stuff. It's very minimalist, and so you can think about the other distros. They are multi-purpose, right? So you can run on a desktop, you can run in lots of places. There was not a very specific to containers distro yet. And the other distros, what they usually do is they take things out to work as a container based image. But in the case of Wolfi, like there is nothing, and then the things are added very meticulously. So we have it's very tight. It is based on APK, the Alpine Package Manager. So that's the package management that we have on Wolfi. But one important thing is that the APK tools is not installed by default. So the distroless images that we build with Wolfi typically don't have a package manager that you can run APK, add, and install new packages because the images are made to be distroless. But this is another subject that we'll talk later when I talk about APQ. So Wolfi, the easiest way to explain Wolfi, I think, is to compare it with Alpine because that's the distro we have based on APK. But the difference is that Alpine uses Muzzle, and Wolfi, as of now, we are using glibc, but we will have a Muzzle also version, let's say, later on. So this is the compilers and stuff. I don't know a lot about that, but I read enough just to understand the differences. And one thing that's I found that is really great at it, you can go to the Wolfi repository on GitHub and you can see actually all the packages that are already available. They are defined as a YML file and they are built with Melange, which is the other tool that I'm going to talk about. So Melange is basically a declarative APK builder tool. We use Melange to build APKs, and these APKs this is like similar to a package that you install with apt, right? On Ubuntu, I think most people might be more used to apt get install, and then in the case of apk is the package manager from Alpine. So it's slightly different the way it works, and it works great for a declarative pipeline because you declare how you want your system or how you want your package in this case, and then the tool will build it for you. I have a few considerations about why APK later on when I talk about APQ. So Melange is part of the building toolkit behind Wolfi and Chainguard images. So this is the tool that builds the packages that are used in Wolfi, but it's not Wolfi specific. You can build APKs to use with Alpine as well. It is multi-architecture by default, uses QEMU, so you can build for several platforms at once, and you can use actually there's a type, the Melange image with Docker, and then you can build from any system. Like in my case, I run Ubuntu on my personal machine, and then I run Docker. I run the Melange image with Docker, and then I can build the packages for any platform. So that was Melange. And then we have APQ. So APQ, I think it's my favorite. I like both Melange and APQ work together, but APQ is like, I would say is the leaf, is the thing that is easier to grasp because you are more used to work with Docker files and build images than you are used to build packages, right? Melange is a bit more complex because you need to actually run, let's say, the steps to configure and build a package from source to build your APK most of times, depending on what you are installing and what you are packaging. So it's a bit more complex, but building doc container images is something that we are more used to. So it's easier to relate to, let's say. APKO uses YML, uses a declarative language based on YML to create images, container images based on the OCI formats that is a standard format for container images that is compatible with Docker and other runtimes. So it is part of the built-in toolkit behind Wolfi. So APKO and Melange together. Actually, APKO is not relevant in the context of Wolfi, but for building Chainguard images, because that's when you are using this tool to generate the images that are based on Wolfi. So the builds are fully reproducible. There are a few different things that enable that. YML it helps because it's a kind of a declarative language, and also you define the state at once. It's not like steps, but it could be. But in this case, we define a list of packages that you want installed on that image, and then the build will only finish successfully if all the packages can be installed. So this is one of the things that APK, the package manager, has different from APT, because when you install packages with APT on a Debian-based distro, then you have steps. You install 1 and you install 2 and you install 3. When you talk about APK, it will try to resolve all the packages that you make a change to the system, and then it will try to reach that state. If some package cannot be resolved, then everything is going to just fail and it's not going to change the system state. So it's easier. It doesn't need to any kind of rollback, uninstall something or do anything, because things will only change if they can be changed, kind of. So the most important things I think about APKO is that they are reproducible, the builds are reproducible, and they generate SBOMs. So what is an SBOM? An SBOM is a software bill of materials, and it contains a list of all the software that is installed in a project, like in a library or whatever it is that we are talking about. In this case, container images. So the SBOM will account for all packages that are in that image. And in this case, it is very reliable, and it's a really high quality SBOM generated, because you don't have like steps like in Docker, for instance, in Docker file. You build an image, so it's mixed build steps and also like composition. So you install packages and you run steps and you generate lots of layers. So APKO is different. It's like a flat image is generated. There are no layers. So it's and also there is no like copy file from one place and add to the image, clone this repository. There is nothing like that. Packages content can only be added through APKs. So that's why you have Melange. You can build your application as an APK if you want, and then install with APKO on your container image, or you can use a Docker multi-stage build to include the software that you need. So that's how you deal. The images are kind of, I want to use the word hermetic, like they are kind of a closed thing, but it's not very proper, the word, but it's something that you don't tamper easily with. So that's the whole deal, like the important bits. That's why this is for production runtimes, not for development. But you can also, of course, you can run it locally with Docker and to try it out. And this is an image that has a kind of overview, more visual, how they relate to each other. So at the center, we have Melange and APKO. Melange builds the Wolfi AP keys that we have in the Wolfi OS repository, in the package repository for Wolfi. And we are building this, it's like all the dependencies. For instance, right now, I'm working on a PHP image based on Wolfi. And then we are there's only one package that it's, so we have to first create the package that is a dependency to have it there on the Wolfi OS repo, and then I can use directly from APQ, like I'm installing an APK just with Alpine normally. But anyways, back to the to the image. So APQ uses the APKs generated by Melange, and then it creates the Wolfi based images. And with Alpine, it's kind of the same thing, but we use Melange to build custom APKs that we want. And then we can still use the Alpine APKs from the official Alpine repositories. And then we'll have at the end Alpine-based images. So this is how you can work. You cannot mix both. You have to stick with either Alpine or Wolfi. Okay, so okay, I have now Melange. So I'm gonna show. I don't have slides, but I'm gonna show some files, some of the packages, and navigate a little bit on the Wolfi OS repository, so you can have a look at the packages. Let me share this one instead. Oh, no, I can just bring this here, I think. Yes. Okay. So this is the Wolfi OS repo, and there's all the packages are here. So you can find, for instance, I really like the Python one. I use that as a base for building my PHP. Yes, this one. So this is how a Wolfi, not Wolfi, a Melange package looks like, how it's defined. Let me see if I can collapse this. No. All right. So we have the metadata about the package, definitions, version. Then we have the target architectures. So you can build for all, or you can limit to some specific architecture. Then license, other things. And then we have like where the things happen really is around here. So we have the repositories where you can find the packages. In this case, we are building for Wolfi, so we are using the Wolfi repositories. And then the packages that we will need to build our package. So this is like dependencies that we're going to need for building. You can also add some runtime dependencies. So whenever someone installs this package, they will also need to bring in those dependencies, the runtime dependencies. This one, so this is where the build starts, the pipeline starts. So we can here we fetch the source file, and then we have already this implemented to kind of transparently check the SHA-256, and then after the download, then we start the other steps to build the package. There's some, I don't know much how to install Python, so there's some stuff here. And then the configure that I remember from old times. It's been really a long time since I don't compile things from source. So has been very interesting to relearn. And then we have all these configured arguments, and then make install, create a symlink. So it's really like you building from source, but then you distribute that into a series of steps in a pipeline. And then you can also build the sub packages. This is something I'm still learning about. But so this one, I didn't build this. Um, so it's a reference that I use it to build my PHP image. My not mine, but from everybody. It's gonna be. Yes. So this is how a YML, a melange YML file looks like. And then once you have these, I'm going to have to share my terminal now. Let me see. No, I can bring it to, no worries. I can bring it here, I think. Yes. Okay, so I have here my terminal. There's a bunch of files, but basically the melange Wolfi, I have a melange Wolfi and a melange Alpine. So this is the Wolfi one. This is for building PHP. Let me see if I can make it bigger. Yes. Okay, so similar to what we saw with the Python one, then I changed the license for the PHP license. This is a work in progress, but it already compiles and the image is being, the package builds, the image builds also. So we have the repositories and the packages that are required for building PHP, and then the fetch, configure, make, install. So I still have some work to do here to figure out if there is something extra that I can remove and things like that. But to run this, I have here the commands. So yes, so this is the command I'm using to build the package. And so it's a Docker run sharing the current directory with /work inside the melange container, because that's a predefined directory where things are output. And then I use the melange image and with the command build, and then I pass my YML. I want to build only for x86-64. And then I also provide the melange RSA key that I generated here. So I have links for the tutorials where I cover all these at the end of these slides, and I will also share on Twitter later. So when I run this, so I'm gonna try to run. I don't know if my machine is gonna, if Docker is gonna die or it's not gonna happen, but let's try. So it's building. This might take a little bit because it's going to compile, run, configure everything. You can see here it's building for only x86-64. And yeah, the build's installing. It's installing the dependencies now.
Yes, and one question from the chat, like, are the
Yes.
melange packages are authorized? Are melange packages authorized? This is the question from the chat.
I'm sorry, I didn't understand.
The question from the audience is like, are melange packages authorized?
Authorize.
Yes.
What do you mean exactly? They are
Yes.
signed?
Yes,
Not
might
sure.
be they try to ask this. So, Hussein, if you had tried to elaborate your question more a bit, so I will definitely answer those as well. So now I think the build is coming up. So
Okay. Okay, actually, there was an error. Oh, I know, because you need to run with extended privileges for this to work with Docker. Sorry, I forgot. I was just making some tests here, so that's why. Okay, let me stop being lazy and do a Control R to find the correct one. So not this. Yes, this you need to append minus minus privileged to Docker run. This is specific to Melange. I think it has to do with QEMU, but I'm not quite sure. I'm just gonna fix something with my headphones really quickly. Um, because when I talk, it stops. Yes, it should be fixed now. All right. Okay, so it's building and yeah, installing dependencies. I think
Yes, I think we
there's
can
an
cover.
S.
Yes, I think one question before is building. One question for the audience. Like, we talk about a lot on the reproducible builds on the internet, and we're talking about a lot. Like, can you elaborate on this point? What are the reproducible build? Like, do you want to replace your base images with updated version and without changing anything? Do we call this a reproducible build, or how do we actually define
No.
people like they are really new to this concept?
Okay. So these tools, they are built primarily for automated pipelines, and in this context it's very important that we can make sure that if we run things twice the result is the same, if there was no change to any version or anything. So the builds are reproducible. It's kind of like that. When you have the regular Docker files, you don't have reproducible builds because the build is based on steps that are executed, and things are gonna change in the system. It's not gonna be the same image exactly. And then when you run even the timestamps and the things, but with APQ, for instance, if we're talking about specifically about container images, then the builds are fully reproducible because and they even generate the same hash, like the same um I think it's hash. I Yeah, blank for words now. So the timestamp doesn't. There was even an issue that we had to kind of someone from the team submit a pull request to Docker because the images show up as like built 50 years ago, but that's because there is no the timestamp is zeroed, so that it's um, so the hashes are the same when the when the image is the same, like because we have nightly builds for the APQ images, and then every night it builds. So if the timestamp changed with the last build, then it would look like the image is different. But we need to be able to attest that the image is the same. No package was changed, nothing was changed. But that with Docker file, if a Docker file, that would not be possible because every build would generate a different image. Does that make sense for the reproducible thing?
Yes, yes, absolutely, absolutely. I think, yes, absolutely. That's because in the Docker, the steps are running in sequence, and they
Hmm.
in the Docker world they actually create a temporary images for the some of the steps, and then it's shut down the container and pull out the ID of that container. And every time it's create a new ID, the hash is changes, and it's letting me know that there are some changes in the images, but this is no images in the images or packages, but it's actually the timestamp is
Hmm.
changed. So I think that's really
Yes.
good concept in the APKO. How many times you run it, you have a same response every time.
Yes. Okay, so the build finished successfully. So what do we have here, right? So we had the configure, make install. That's basically what the build did. This part of the end is the make install part where it installs the no here. Yes, I think installing the commands. Yes, so you can see where the stuff is and like what is generated. The index. Let me just show. So inside of packages, it will have the architecture, and then if you build for multiple architectures, then You have multiple folders here, each with an architecture. And then inside of it, you have the packages. We have multiple ones because there is, I had to build the libxml2 as a custom package as well, but this lib is going to go to Wolfi OS repo, the packages repo, so I don't need to build manually. So this is being built as well. And then the sub packages dev and doc for libxml, and then PHP 81. So this naming is still, we don't didn't settle for a name yet because the PHP on Alpine is PHP 81, the package. So I'm not sure yet if we're going to use just PHP. Well, let's see. This is something that we are still figuring out, the tags and the names for the packages. It should replicate Alpine or not. And then the APK index is very important also because without the index, APK is not able to to locate, let's say, to resolve the packages. So the APK index is automatically generated by Melange when you build. It wasn't before and had to build manually, but it's something, is a feature that people in the team implemented. So it's very handy. Okay, so this builds, and the other files that some other files I have here are from APQO to test it. So this APQO glibc is the container building file that generates a container using this package. Container, no, image. But I'm gonna go back to the slides to talk about APQO. Then we can come back here to test the package with APQO, right? Okay, so let's go back to the slides. Yes. So APQO. This is the original talk that I had prepared. So this is an example of an APQO.yml file. And like, if I would say an entry point for you to try any of these stuff, that it would be through APQO, because as I mentioned before, is the thing that is more relatable. You're going to build a container image that you can test locally, and it's you like in practice you'll be using more, you've been doing more APQO files or even Docker files that are based on an APQO generated image, because the Melange packages, we eventually will have enough dependencies and packages on the Wolfi repository that you won't need to be manually compiling stuff. But yeah, so APQ. You have a similar structure in the YML file, the repositories that you want to pull from, and the packages that you want in your image. This is a very simple example of an Alpine base image. This is gonna only give you like log you in a little shell that you can run some commands with the Alpine base package. That this is gonna have basic commands, ls, things like that, so you can navigate a little bit on the image. And yes, so there is an environment section where you can define environment variables. There is also entry point. And this is how you build the image with Docker. So you can, like the Melange demo that I run, you can use the distroless APQ image to run APQ and then generate your image. And yes, so you pass the command builds, and then you give the YML file, and you give a tag, a name of the image and a tag, and then in also a tar file, a name for the tar file. The image is going to be generated as a tar file, and then you load it into Docker to test it. So this is how the local testing works. Yes, so as I mentioned before, these tools, they are more for production runtimes, but you will have to test the images locally, right? If you are going to build them, custom images, then you need to try and test them. But then you can set them up for auto builds like we do in GitHub Actions. We use GitHub Actions to do nightly builds. There is also APQ GitHub Action that you can use to build automatically and upload to your Docker Hub account, for instance, or the GitHub registry as well. Okay, so this was the slide I had about why APK. So I talked a little bit about this before, but it uses a different methodology to handle package management, and that's why it's ideal for declarative and reproducible pipelines. So I don't know if you um, use it maybe Ansible before. Like I remember sometimes I compare a little bit because with Ansible you had a system. You run every time you run is a declarative, and then you try to reach a certain system state. That's how also it works in with APK. Kind of, it will you have a file that has all the packages that the system must have, the roles, and then when you make changes, you either add or remove packages. This roles is gonna change, so it's gonna try to reach that desired state. And if it cannot reach a package, cannot resolve a package, then it's going to fail right away. And it's going to fail and it says something like broken roads, fail fixing roads, something like that. Yes. As the first time I saw the error message, I was like, what? Broken roads? What that means? And then, yes. So that's how it works. Okay. Where do packages come from? I also talk a little bit about this already because this talk was before and I didn't have that image. But the image, I think it shows better the diagram with all the projects, because you can have both Alpine and Wolfi based images and you cannot mix them. You can use generate Alpine based with all the regular Alpine packages, or you can look at the packages that we have at Wolfi, and you can already you can already compile a bunch of stuff. But there is some dependencies, libraries here and there that we are still building, like that libxml2 for PHP, and other stuff also uses it. And yes, so you can also build your own APKs with Melange if you want. Then it will depend on your system, what you're gonna do, what's your purpose. A word about why distroless also. So the distroless, some people, when you say the word distroless, you think about the Google distroless images were the first ones like these, but it's more like when we say distroless now, it's more like a philosophy or a style that talks about images that are very minimalist and that they have only what's absolutely necessary to build or to execute your application on production environments, mostly build and production runtime environments. So popular based images are full of software that only makes sense on bare metal servers, because you think of a full distribution like Ubuntu, and there's lots of packages, even though a bunch is taken out for the container-based images. Even in that case, there are still lots of things that don't need to be there. Like you don't need a package manager for your production image. You shouldn't make it so easy to install additional stuff there. It should be really tight to run your application, only that. That's the ideal scenario, right? And this is not because of size, but it's because of the attack surface. So the smaller it's the attacker surface, the more safe the image will be. There is no way to go away from this. The more dependencies you have, the more the attack surface. There's more entry points for having malicious code, infections, anything. And also regular CVS, like bugs that are found and whatnot. So The less, the better. And that is difficult for development purposes, of course. So that's why these are more for production. If you are debugging and you don't have an ls or a cat or anything like that, it can be really hard. So you can, like in my case, I built a few PHP distroless images, and I made a companion slash dev that has more stuff for debugging, and that helps Composer, other package managers and stuff. So you can work with um, a dev image for building, and then you compose a final image that is smaller with only the artifacts that you from the builds, something like that. You can play around, and also with Docker files, but basing your Docker file on a distroless image. As long as you find a way to get your stuff there, like your custom files there, because normally you cannot install extra, but you can create a composite image with a Docker mood stage build. And this is an easy way to see the difference. Nginx latest and the Chainguard Nginx latest. So this is, you can run Trivi locally on your command line. You can go to their web online also tool and run yourself, and you're gonna see. That doesn't mean we aren't always zero CVS, our images, because CVS will always show up eventually in here or there. But if you have a small area for attack, a small surface, then there will be less, a lot less. And if the images are built every night, then the fixes are coming also quicker. So that's the beauty of it. With all the things, when all the things come together, it requires a little bit of automation, of course, also to update the images, but then you have something like that's a lot safer. And this is more of a case study. I'll go briefly, so you have some time. So I'm gonna show what I did in my specific use case. So I have an application called Dynacover that is a app that creates dynamic header images for Twitter. And it runs on command line. It was built with PHP, and there's just a few dependencies, but uses GD to generate the images, curl to make requests to the Twitter API and the GitHub API. So it shows my latest followers and GitHub sponsors. And this is updated like every 5 or 10 minutes. So you can actually see my new latest followers there. And it runs on GitHub Actions. I mentioned that already. So it's a container. I had this container image on Docker Hub on my accounts that I was using. And yes, it runs on schedule. So I was using the official PHP 7.4 CLI image. It's been a while that I built this, so I hadn't migrated for PHP 8. I migrated recently. And this is how it was before. So I had an official image that you think, well, I'm going to use the official image, right? PHP. But the thing is that those images, at least the PHP ones, they are based on Debian or Ubuntu. I don't know for sure now, but it's really huge, like almost 600 megabytes. And the CVEs detected by Trivi were like on the 300s, hundreds of CVEs. And yeah, that's a lot. So what's the steps? Like, let's migrate, right? So the first step actually was updating my app to PHP 8. But yeah, once I had the app running on PHP 8, then I also had it with a Docker file based on Debian. So I had to also change that. So I collected all the dependencies I had. This is, you cannot even read, but that's you don't need to read this Docker file. It's a bunch of like apt installs and run composer, things like that. So first I collected all the dependencies I had, and look at this for finding searching for these dependencies on the Alpine repositories. So first, this case specific I is on Alpine yet. This image at the end that I'm going to generate is Alpine based. It's not Wolfi based because I'm still working these final things for Wolfi PHP image. So we're talking about Alpine here. So I searched for all the dependencies here and I found the equivalents. So I created the apq.yml file and I need packages from the main and the community repos on Alpine. And these are all the packages already, if they're equivalent Alpine versions, everything that I would need. And then I had the entry point, also the PHP, the regular PHP Alpine package installs as PHP 8.1 in the case because it's the 8.1 version, 8.1. So I added the entry point, set the environment, and I also set some accounts, actually one account if a regular user, but then I set it to run as root because when you create a Docker file from this, you still might want to install things. That was my thinking, like copy, do some extra stuff. So it's easier for you in the Docker file to just change to the other user than to set it to run as the regular user already from the base image. So, and then run as root. Yeah, run as root is to by default run as root. And there is one typo here. This PHP 8.1 PCNTL should be a dependency on the other screen. So, anyways, so when I got that apq.yml file ready, then I run this command to build it, and the same way I showed before, and then I pushed it to Docker as well to my account. Okay, so step 5 from the migration I did was to update the GitHub Action Docker file. Before it was from from PHP 7.1, and now it's from Erika Heidi Minikli. That's where I put this image. And what I do here, I copy Composer from the official Composer image. This is something you can do because you are using a Docker file now to compose based on the distroless image. And I'm not using APK here. I could not do like APK install Composer, or this would not work here. But I can still copy artifacts from other images. This is fine for using with Docker files and distroless images. So I run git, and then I set up entry points and the commands. So this was the Docker file. And now I have, it's hard to see, but the steps, the boxes, they show in the top, the smaller box is the step that actually comes from the distroless image. And then the step 2 is the step to copy from the Composer image. So if it pulls a bunch of layers, you can really see the many layers that the simple action of copying the Composer file to my image, it brings out a lot of layers, but that's fine. I don't mind that much. But you could also optimize that if you put Composer already on the distroless image. But that was not the what I wanted to do. All right. So this is the most important slide of all the presentation, before and after. So before, the image was 589 megabytes with 331 CVEs detected by Trivi. And at the end, the result was a 48 megabytes image and 0 CVEs detected. So this was one example, one use case for a personal project that I have, a side project, and it worked very well. And I can even begin to imagine the many projects out there that could benefit from an update like this. And also, like, I know there are probably not many PHP developers listening now right now here. I don't know, because I am a PHP developer. For before I started working for DevOps and documentation, I work as PHP engineer for many years, and there are lots of security concerns in the PHP land, of course, with WordPress and especially and other things that bring in lots of code from external unverified sources. So it's this is one thing that we can do to improve that. There are other things also in software supply chain security that we can do, of course, but dealing with your images, like making sure your images are safer, it's one thing important that you can do already. It doesn't require too much effort if you look into the benefits. um yes, so here are some links, then I will share the slides later, also links on Twitter. And I was also going to say that if you think that's too complicated to build, that's also look into Chainguard images, because we already have a collection of curated images that you can see if you can find something that works for you, so you don't have to build everything from scratch. So yeah, that's why we built Chainguard images. And yes, I think we can open for questions now. That was pretty much the whole thing.
Yes, absolutely, absolutely. That's super interesting. That's the last slide actually depicts the story because the way we are approaching the container is really differently before the arrival of Chainguard. Because what we do is we're making sure we're spending time on multi-state Docker file to making sure that the size of the image that we build from is MBs inside. But actually, the problem is not with the container images, but the base images as well, because they are giant in size, like 600 MBs or 800 MBs. Whatever logic and whatever engineering you can build into the Docker file, you end up having 600 MBs plus 200 MBs code, and that's 800 MBs. And then it passes to the container scanner, it detects 313 vulnerabilities. So we see in that time a lot of the vulnerability scanners come into the market to tell people you are doing wrong in your container images. Let's try to fix that. But I think the chain guard is really the company behind and the folks behind the wonderful engineering. Don't think about container scanners. How do we eventually make sure the size of the image is getting smaller and smaller? I have 10 MBs of images on the Chainguard images side, and when it last time passed through the scanner, the zero vulnerabilities is found because there is very, very minute container in there. So I think the way the team is approaching this container ecosystem is really, really inspiring for all of the folks because they think about let's make sure what your container images just need. Because putting so much effort into the container and the attacking surface is so much large. And then you end up going engineering to reduce attack surface area and these. But I think that's really a wonderful story about how we started about the APKO, Melange, and now the Wolfi. And I think the Wolfi is kind of the base images that people might want to upgrade their base images to because these are so tiny in size. And also, like I think we try to address some points because in this moment of time, some of the people are using Docker containers. How do those people, the beginners and the startup companies, they migrate into the Wolfi container images? Because they might see a learning curve involved in here. Not a much, but they need to think about how the Linux work behind the scene in able to be more productive in it. So, what's your strategy? Because you tell your migration journey so far, how you take your app and convert it into the chain guard images, and you and show the result like zero CVEs are found. But for the companies and the startups and the people or learning container technologies, what their journey is going to so far? Because everybody jump into the Docker first, and then they realize there are some security issues in the Docker, plus the way they build the images is also. So, how you recommend to the people who are to people like how they eventually join into the Chainguard images and start using from tomorrow?
Yes. So as much as we'd like to have like upload your Docker file and then just convert it to, it's not as simple because the philosophies, let's say, are fundamentally different. So depend on, everything depends, I hate to say that, but it depends on your stack, and what's your use case. In my case, it's PHP. So PHP runs. I have to install the PHP and a bunch of extensions. So I already I have to know already which extensions I'm gonna bake into the distroless image, because I won't be able to add more extensions later because these are installed as system dependencies. However, the composer, the userland dependencies are installed as at userland with composer, is not system wide, so I can still copy from another image and throw them into a composed image. So there are a few different strategies. Migrating will really depends on your specific case. But if for a pitch, for like a, if you are looking for how to pitch that to your managers, to your company, it's really nice to have a look at the scan comparisons, because then you can really show. Trivi has an online version of their scanner. Then you can just put their in one of the Chainguard images and compare with an equivalent, and then you see and you can show uh, the people who are in charge, if that's the case. But it requires a bit of thinking on how you're gonna build that. There will be a learning curve and figuring out, because what happens is that when it comes down to really knowing, nobody knows exactly what dependencies they are depending on. Like you have an idea, right? You have an idea that you depend on a few extensions, but it's always more than you think, because those extensions, those dependencies depend on other dependencies. And then and there's also stuff there that you don't even know that's there. You install it once. It comes back to the issue you have on it works on my machine in the past, that you could run, everything would work fine in your machine, but on production it would not. And there was this difficulty to figure out which packages were missing, which dependencies were missing. And when you're going to migrate from one base image, no matter which image it is, because I also migrated from Debian to Alpine, and it was also a pain initially. The first time I didn't even know, like, there's no apt here. How I'm going to install a package? And then, oh, it's apt now. Okay. And the things work differently. So there is always a learning curve. And when migrating to Wolfi, if you are from Debian, I would suggest migrating to Alpine first in a Docker file. Then when you have your stuff all built in on Alpine, it's going to be easier to migrate to Wolfi, because at the end of the day, it's a bit similar. I would say that the closest to Wolfi is Alpine. It's still different, but you should migrate first to Alpine, then you start building your Wolfi version of it. So I hope that's helped a little bit.
Yes, absolutely, definitely. And some of the community people, like from the six store community, developer guy and Furkan Tadkol is on the chat. And you guys are late. You can watch the recording afterward as well. It's been as well. And I think like it's definitely like always been a learning curve involved. But I think that all the effort that we are putting on is really, really important, because one of the things that we are doing currently is at this moment of time, we're reducing the attack surface area and then giving you the opportunity to install more things in it. Because previously there is a critical debate within the community, like if we remove, let's say, terminal from the images, how do we troubleshoot that container? How do we able to find like what actually happened when something wrong in the production or in the local development environment? I don't able to understand what is happening, why my container is not running, because some of the processes are running on the system-based services or some other services that need to be in that image there. But right now, I think the Kubernetes is moving to the ephemeral containers, the debugging containers we can
Mhm.
attach into it. This is actually solved. And now I think more and more focus towards the distroless, the images from the scratch. That's another whole lot of field now, how you make sure your containers are popping up. But I think it's all the pitch behind this is you look at your images as of today, they're not 10 MBs in size. There might be 200 MBs in size. Why do I care about it? You have to care about it because the use is adding more stuff into it, which eventually need you to pass through the scanners, and the scanner detects some of the vulnerabilities. And for the some people, they might be frustrating because they think, "Oh, I have done my job. Why do I stay late here and fixing those vulnerabilities that are not mine? That are for the some package manager. And whom should I blame to?" So I think moving this conversation, like if you go to the Chainguard images, they are 10 MBs in size. You can add stuff into there. Now we have ephemeral containers to debug the troubleshooting issue. So I think everything is in place, and also they give you some SBOM, and plus there are tools in the six-store community to sign and verify those containers. So I think as of today, I'm really really happy. The whole supply chain security picture is quite clear because previously I afraid because if you look at the container ecosystem, there are 17 different tools for the networking, 17 different tools for the container runtime, and I'm thinking like if something pop up in the image scanning world, it's image verification, there might be 17 different tools. Whom should I choose and which one is fit for me? And now I'm really happy. Cosign is the only place for the people to sign the images. So I think the picture is quite clear at this moment of time, like what is happening in the ecosystem. And also, I think the six store community is the best place for to ask question about these kind of concept. And the Twitter handle is uh, Twitter is a place to talk with Harika and all these kind of things. So before I let you go, we have 2 more months remaining for this year. So like, what is your roadmap for the how you closing down this year's, and what is your roadmap for the next year?
Like me personally or Chainguard? Well, I can talk about my personal goals inside this context. I have some more documentation lined up for Melange, and I did an updates recently. I pushed an updates through APQ last week, and I should have some updates for Melange as well soon. And I also want to write a little bit about how to automate building images, something that I also managed to do in this in a personal side project. And yeah, so more content. We are also trying to think of a recurrence kind of meetup or office hours where you can connect with the audience, with the community, about different open source projects that we have at Chainguard. So we are thinking how to make this happen, but we are excited to um, start getting more involved with the community, and yes, like doing few more educational events or like resources, building something different, videos, maybe things like that.
Yes, absolutely, absolutely. And I would definitely encourage people to look at your Twitter handle because more education content you put on every tweet has been a very informative one. So I will encourage people to follow about Chain God and Erica on the internet. So before we let you go, here are some quick resources for you. You can go to the sixstore.dev to learn about all the supply chain security wonderful community, and they help you a lot in your journey. There is an official announcement from Chainguard introducing Wolfi. I think encourage you to check it out, like what are the details in here and what is the aim for the Wolfi. Plus, there is a six con happening at 25th of October, and wonderful talks are always been in there. So please join that. Here's the Chainguard website. Here are Chainguard images that are very, very 10 MBs inside and don't need a scanner for that. And also the Twitter handle for the Chainguard. And this is, I think, the Rocco Day YouTube channel. One of the Chainguard member, I forgot about his name, and he's introducing APICO and Melange live stream. You can check out definitely. Melange Go packages is the link for that. Main package repository for production Wolfi images. And this is a wonderful blog post on Chainguard, securing your software factory with Melange and APICO. And all these links are available on this YouTube chat. And this is the last place where you see cosine, record, full SEO, and cosine is one of my favorite too. So thank you very much, everyone, for tuning into this podcast. I really enjoyed the time talking to Erica and learned a lot about APKO, Melange, and Wolfi. And we'll get in touch with you in future as well. And hope to get you again on back on this show and talk about more things. Thank you, everyone. Stay safe, stay healthy. Bye bye.